Hi guys, how are you doing? I hope you're amazing. I know there's been a while since I haven't posted as I was busy doing some stuff. But anyway, today we're going to talk about a probability distribution. This is going to be the last video of statistics section. And from next video, we'll be starting Python programming related to data science. Although one more video might come in which I will explain you some numericals of this probability distribution. So make sure you subscribe to my channel. Now let's start with what probability distribution is. Okay, so a probability distribution depicts the expected outcomes of possible values for a given data generating process. And why do we use in data science? Let's have a look. You know, analyzing the distribution of your data is important because, have a significant impact on the result of your analysis. Understanding the distribution of your data can help you choose right statistical tests, identify outliers, check for normality, and visualize the data. I hope you got the sense. Now, when it comes to its types, there are mainly five types, which is normal distributions, binomial, Poisson distribution, exponential, and uniform. And we will talk one by one of them. So let's start with normal. The normal distribution is symmetrically shaped and characterized by its mean, which is denoted by mu, and standard deviation. I don't know what the symbol called, but I hope you know. It is widely used due to its mathematical tractability and represents many natural phenomena such as heights, weights, and test scores. This is what it's used for. And in the other side is the binomial distribution. The binomial distribution represents a number of successes in a fixed number of independent Bernoulli trails, and which each trail has two possible outcomes, success or failure, with a constant probability of success p, which is denoted by. It is used to model great data such as the number of heads in a series of coin flips, or the number of successes in a fixed number of experiments. I hope it will be more cleared when I will show you and I will explain you these of them, numericals of them. But for now, let's move forward with Poisson distribution. The Poisson distribution models the number of events occurring in a fixed interval of time or space. Given a knowledge average rate of occurrence, lambda, it is often used to model rare events where the probability of occurrence is small but the number of trails is large, such as the number of phone calls received by a call center in an hour or the number of accidents at a specific intersection in a day. I hope that you're somehow getting it. Number 4, exponential distribution. It represents the time until an event occurs in a continuous process given a constant rate of occurrence denoted by lambda. It is used to model the time between events in a Poisson process and is commonly applied in reliability engineering, queuing theory, and survival analysis. Now we come into the last one, uniform distribution. It assigns equal probability to all outcomes within a specified range. It is characterized by its minimum and maximum values and is often used in simulations and random number generation when all outcomes are equally likely. I hope you got some information in this video about the probability distribution. I hope it somehow cleared your, doubts about it, but I hope you like it. So for more better understanding, you need to stay tuned for the next video in which I might bring, the numericals or solution for these distribution to make it clear. Now for now, thank you so much for watching. If you haven't subscribed or shared, just make it happen, please. Thank you so much.